Alright, so in this video, I'll be showing you how to use the Euler method in Excel. And the method is just used to solve differential equations given initial values. So for example, in a reactor, if you know the concentration at t equals 0, at time equals 0, or something like that. But here we're given our ODE to model, and we're given our initial value, which is the value of something we know at initial conditions. So let's say at time equals 0. So y, whatever y is, it could be concentration, is 1 at time equals 0. That's what it means. And step size is at what intervals of time, let's say t is time, we're investigating or evaluating y. So at t equals 0, 0 0.5, 0, 1, 1.5, and so on. And the range. So let's say t is time, so we're evaluating y from t equals 0 seconds to 2 seconds, for example. So what you want to do first is make this table here, and afterwards start by saying this is our first iteration, and ti here is 0 because we start at a time equals 0, and as you can see here, at t equals 0, y is 1, so we put 1 here, and in this bracket we just evaluate this function here. So what I mean is we just substitute all the yt values here. So y times t raised to 3 minus 1.5 times y, right? So basically what this equation is above, enter, and afterwards we just multiply this here with h, our step size. So we do that, times here, our step size, 0.5, and make sure to $sign this because it's going to be a constant value, it doesn't change. So do that there, enter, and then we start with our second iteration, so write down 2, and here ti is just 0 plus our step size, right? So we just do that, $sign it as well because it's going to be constant, and here yi is this 1, or this value here, plus this value here, and we get this from the formula here, right? So it's yi plus this h and whatever is in this bracket. So we just do that, and then here we just have to drag these two down, and for this we're done, right? So we just have to drag it down until t equals 2, right? Because it says here we have to do until t is 2. So we do that, and we're done. We get our we've modeled this ODE, and to even make it clearer, we can just visualize it by drawing a graph. So let's say we put a graph like this, and select data. Let's put this over here, and our x values is t because it's the change in y over t, so t here, and our y values, well, is y, right, because we're evaluating y with change in t. So we do that, and we get our graph, right, and the graph looks, well, relatively correct, right? The concentration or whatever that is decreasing. So that's it for the Euler method. Thank you.